just when we thought we were past acceleration, we spent quite a few days talking about acceleration earlier on a week or so ago. Just when we think we're past that, now we're back. We're talking about the other day acceleration due to gravity. We learned that really when an object is falling from somewhere or rising up in the air under the influence of just gravity, then it's really the same problem as we've been solving for the last week or so. It's a group B problem. But now when we're solving one of these problems involving up or down motion and just gravity, then what we got to realize is that we have an automatic given, a given to us every single time. And that is the fact that the acceleration is negative 9.81 meters per second squared. Can anybody explain to me why the acceleration is negative 9.81, whether it's accelerating downwards, right, speeding up in a downward direction, but it's also negative 9.81 as the object is rising up into the air? How come it's negative in both cases? Shouldn't it be positive when it's going up into the air? Yeah, in the end, what's causing it to accelerate downwards or decelerate upwards? It's gravity. And gravity is a downward force. And a downward force causes a downward acceleration. Even if something's moving up into the air, moving upwards, the velocity is upwards, but that doesn't mean the acceleration is upwards, right? The velocity is upwards, but the acceleration in that case would be downwards because the force is downwards. That makes it a negative acceleration. We say that in general, when an object is speeding up in the negative direction or when it's slowing down in the positive direction, like a projectile is, something going up into the air or down in the air, we say that it's a negative acceleration. And in this case, negative 9.81 meters per second squared. There's one thing that sometimes is actually quite important that we're ignoring in all of these problems. What is it? Air resistance. And air resistance is affected by a bunch of things. The mass of the object. Air resistance is affected by the surface area of the object. It's affected by the speed. The faster it's moving, the more air resistance there is. That's why we reach, as something falls from a really high building, it reaches a terminal velocity because the air resistance becomes bigger as the speed becomes bigger. We're dropping that, right? We're ignoring that because that becomes really complicated mathematically. And you know what? In most cases, it's a pretty good approximation to drop the air resistance. All right, we got a couple questions for homework on page 58, 3 of them actually. I want to take a look at those questions now. Which one or ones of these do you want to go over here? 2? 3? 2 and 3? Okay. Number 2 says, having scored a touchdown, a football player spikes the ball in the end zone. If the ball was thrown down with an initial velocity of 2 meters per second from a height of 1.75, how long is it in the air? All right. That's a good question, actually. Who asked me that? Taylor? No, who asked me for number 2? Bruce? That's a good question. I think the way that we're going to try to tackle it first, we kind of come to a bit of a dead end. So we've got to try something else. And that's useful to go through something like that, actually. All right, what do we got here? This is a group B problem, right? Because the ball is accelerating as it goes downwards towards the ground. And if it's group B, then we know we're going to use one of those acceleration equations. We also know that the acceleration of this ball, once it's released, is neg 9.81 meters per second squared. Now, it's going to accelerate while it's in the football player's hand, too, but not at 9.81, because when it's in his hand, it experiences a force in addition to gravity, right? It experiences gravity, but it also experiences the force of the hand. So while it's in contact with his hand, we can't say A is neg 9.81, but once it's released, we can, because his hand is no longer acting on it. What do we got here? Something's 2 meters per second. What is that? V, VI, VF, Kessler? That's going to be VI. 1.75 meters. What's that? Distance, let's call it the displacement. We want to find out how long it's in the air for, delta T. Is there any mistakes up here on the givens? There is. There is at least one mistake. Everybody spot it? Emily? Yeah, the displacement is negative because the ball ends up below where it started, right? Anything else? Good. The initial velocity is also negative because it says the ball was thrown down with an initial velocity of 2 meters per second. They're both negative. That's important. You might not think it's important. Look, it's the same number. Who cares if we got a positive or negative? Okay, it's a big deal. It makes a difference. Most times it makes a difference. Okay, looks like I want to do this equation. T is equal to VIT plus 1/2 AT squared. Hold on before you write this down, though, okay? We've got D, we've got VI, we've got A. We're solving for T here. My problem is I don't know what T is, and it's in two places. And VI is not 0. How many people have ever seen this equation, the quadratic equation? How many people have ever seen that in math class? If you've seen that in math class, you can actually solve for delta T there. If you have not seen this in math class, you have no hope of solving for delta T with this equation. How many people tried that equation first? I mean, it seems to me the most obvious one, right? Because it's the one that fits the givens the best. But it doesn't work for us. What have we said 1,000 times before? When we try something, as long as we're trying one of the correct group B equations, and it doesn't work for us, try something else. Try something else, right? Now, we will try something else. And if we do, it's going to end up being a two-stepper, I think. Find something and then find something else. What do you want to try? Yep. Okay. You're doing this, and that's going to allow you, it looks like, to solve for VF. Is that the right way to go? I don't know. I don't know if it's the right way to go. It doesn't matter. Right? It doesn't. I shouldn't say it doesn't matter. Of course you want to be on the right track right away, right? But in the end, if solving for VF doesn't do anything for me, it's okay. It just means that I've spent a little bit of, 90 seconds of my life. I know I'll never get it back. 90 seconds of my life, though, is not that big of a deal. So if I end up solving for something that I don't end up needing, oh well. Why did I drop the negative when I went for the 2 there when I put into VX squared? Not because it's squared, no. Although if you square a negative, it becomes a positive, right? But why did I drop it, though, Danny? No. VF's going to work out to be positive there, actually. Why is VF going to work out to be positive? Moving downwards, why is VF going to work out to be positive? Pardon me? No? There? Because it's speed, right? VF is final speed. VI is initial speed. We don't want the negative in there when we're putting in speed, right? So let's solve for VF. Bruce, do you have the answer for that? 6.911915. Good, thank you. So that's the final speed. Now, we can make it the final velocity by putting just a negative in front of it, right? Okay, is that good? Now what do you do? Now, actually, I think it's a pretty straightforward question. Now all we're going to say is, I think, probably just A is equal to delta V over delta T. Solving for delta T, the T goes up by multiplying, and we switch places with the A. T goes up by multiplying, A goes down by dividing. Delta V is negative 6.1915. Subtract. Oh, careful here. Careful. Negative 6.1915. Subtract 2 meters per second. Divided by neg 9.81. Is that right? Goodness, if I do that, I think I get the wrong answer. What's wrong? Yeah, good. You got to subtract -2. Just because we have a negative there because it's a subtraction, it doesn't go with the 2. It's just a mathematical operand, right? I think when we do this, we end up getting 0.43 seconds. I'm just curious, there was a couple of you that have done the quadratic equation math class before. Did anybody actually try using that for this? No? Did you? Did you end up getting it? No. Okay. I'm not even going to show you right now how you would do it properly with that because so few of you have seen that. There's only a couple of you that have seen that. If you're curious, then I can show you sometime individually, but I'm not going to show the class because it's not going to make any sense to everybody else. So. Okay, number 3 was the other one we wanted to go over. It says an elevator is moving downward at 4 meters per second, experiences an upward acceleration of 2 meters per second squared for 1.8 seconds. What's the velocity at the end of the acceleration? How far does it travel? Can I erase what's on the board there? Okay. This is a group B problem. It's accelerating. Let's write down some givens here. VI is -4. The acceleration is, 2. Is that? First of all, why isn't it -9.81? Yeah, Alex? Yeah, it's moving downwards. It's accelerating upwards, right? So they're telling me that there's something other than gravity acting. If you're in an elevator, let me tell you this. If you're in an elevator and the only force acting on you is gravity, you are in trouble because you're going to go for a little free fall ride. Now, depends on how high the building is, for 2 or 3 seconds, it might be kind of fun, but it doesn't end well. If there's just gravity acting, you're going to accelerate downwards at 9.81 meters per second squared. And if the building happens to be, let's say, 60 meters high, which is about 20 stories, then you're going to be moving somewhere in the range of 100, 120 kilometers an hour when you hit. That's not good. The elevators have cables, and those cables apply forces in addition to gravity. This is not a gravity problem. They throw this in here to see if you can recognize that this is not a gravity problem. Is that acceleration that we say is 2 instead of 9.81? Is it negative or positive? I'm moving downwards. That makes the acceleration negative? It says it's an upward acceleration. Does that make the acceleration positive? It's moving downwards. That makes the velocity negative. It's accelerating upwards. That makes the acceleration positive. You can be moving downwards and experience an upward acceleration. What's going to happen? You're going to keep moving downwards, but you're going to slow down and probably stop, right? That's still an upward acceleration as you continue to move downwards. All right, our time interval is 1.80 seconds, and we want to find VF here. I think we want to find VF, and we want to find delta D as well. So let's say probably VF squared is equal to, no, we're not going to do that actually. How about A is equal to delta V over delta T? Let's solve for delta V. Becomes A times T. T goes up by multiplying. 2.00 meters per second squared times a time interval of 1.8 gives me 3.60 meters per second. All right, that's not my answer, right? We know that delta V is VF minus VI. We want to find VF. VF is delta V plus VI. It's 3.6 plus -4, which gives me -0.400 meters per second. Make sense? So we're saying here at the end of this 1.8 second time interval, the elevator is still moving downwards, but it's moving downwards slower than it was before. Why? Because it had an upward acceleration in the positive direction. If it had accelerated for much longer, what would happen to this elevator? It would have stopped, right? How far has it traveled during this time? What do you want to do here? I think I want to go d is equal to vit plus 1 half at squared. Anybody else do that? Got a couple of options here, right? Now that we have vf, we could say vf squared is equal to vi squared plus 2ad. Doesn't matter, right? Doesn't matter. This allows me to not rearrange. Vi was -4. Time interval was 1.8. A is 2.0. Be careful to make it positive. T is 1.8. Let's do this on the calculator here. -4 times 1.8. Let's press enter. Add to that brackets 0.5 times 2 times 1.8 squared. Press it. -3.96. What have I just found? The displacement. What am I looking for? How far has it traveled downwards? Really the distance, right? Really, I should drop the negative sign. Is that a big deal, though? No. Would I mark that wrong if you left the negative in there? No, not at all. Here's another one. It says a clown throws a ball upward at 10 meters per second squared. What's the maximum height the ball reaches above its launch height in the time that it takes? This is an interesting question. We want to find two things, the max height, and we want to find how long it takes to reach the max height. And we only have one given. The upward velocity is 10 meters per second. We have what? Okay, we have two givens. What's the other one? Good. A is -9.81. Good. This is a group B problem that involves acceleration. Specifically, acceleration of -9.81 meters per second squared. Good. That's critical that you notice that. VI is plus 10 because it's thrown upwards at 10 meters per second. We want to find the max height. What would you call the max height? A variable that we've talked about, a variable that appears in one of our equations. I don't want to call it h because that's not in any of our equations. Okay? Yeah, let's find the displacement and the time. I got two variables given to me. There's two variables I want to find. Let me give you a little hint here. There is something else you've got to catch here. You've got to read between the lines in this question and catch something else. There's another given here. I see a couple hands up. I'm going to let everybody take a look at this for a minute before I call on somebody because I want everybody to kind of work through this themselves, and then I'll call on somebody to give me the answer to that. Nicole, what is it? Good. Excellent. VF is equal to 0 meters per second. If we're analyzing the trip up, look at the pen in my hand right now, okay? The pen in my hand is moving upwards, but it's slowing down as it goes upwards, right? So it's moving at 10 meters per second. Oh, but it's slowing down, slowing down, slowing down. 5, 4, 3, 2, 1, and 0. It stops. And then what happens to it? It starts falling. We're not saying that this thing is going to be at 0 meters per second for long. It's just for at the end of this trip upwards, it's moving at 0 meters per second. It stops momentarily. And we're only going to analyze the trip upward here since we're looking for the max height and how long it takes to get there. So VF is 0. What do you want to do here? VI, VFA, D, probably going to be VF squared. So you go to VI squared plus 2AD. Solving for D. Well, here's a good one to rearrange. We've done this before, but what do you get rid of first? VI, take it over by subtracting. And then we got to get rid of the 2a. We take that over by dividing. So it becomes VF squared minus VI squared over 2a equals delta D. So what do we got here? VF is 0 squared minus 10 squared over 2 times neg 9.81. Neg 100 divided by neg 19.62. It's about 5 point something, 5.1. Is it? What is it? 5.1 meters. And look, it works out to be positive. Negative by negative is positive. Oh, you know what, actually? Let's do this on the calculator, because I got a feeling that people are going to do this wrong. What are you squaring here? The 10 or the neg 10? The 10, right? It's not inside, that negative sign is inside brackets, so we can't square that. It's going to be 0 minus 10 squared. Don't put brackets around the minus 10. That gives out to be negative 100. Divided by brackets 2 times neg 9.81 comes out to be positive 5.096 meters per second. Two significant figures. Oh, wait. It shouldn't be two significant figures, should it? It should be 3. It should be 5.10 meters. Why 3? I see a given there of 10.00. That's 4 digits. Final answer should be 3, though, because we use 9.81 or neg 9.81, 3 digits. The time, I think for this one, we're just going to do A is equal to delta V over delta T again. The T goes up, the A goes down. 0 minus 10, final minus initial, over neg 9.81. And that's going to give me around 1, like 1.1, 1 point, what is it? 1.02. And that's positive 2. Well, and behold, time is always positive, right? Problems here. See what you can do with one problem. All right, the question says the slingshot, which is some kind of amusement park ride, drops riders 27 meters from rest before slowing them down to a stop. How fast are they moving before they start slowing down? So it's kind of like this. Here's the ride. This is a 27-meter interval free fall. There used to be a ride like this at West Edmonton Mall. They took it out and put a new one in to replace it. I always liked this one. It's actually, the ride is actually 39 meters high. But after 27 meters, the track goes around like this, and they start slowing you down. So it's 39 meters high, but at the point where you begin to slow down, you've only traveled 27 meters. Make sense? Okay. And then you actually go up like this and then down, and it was kind of a little bit crazy, actually. This problem exists only in this section. We don't care what happens. We don't care what happens down here. Okay, we only care what happens during that 27-meter fall. So I'm going to erase all this. I'm going to say my displacement, regardless of what happens after I begin to slow down, my displacement ends up being negative 27 meters. My acceleration is negative 9.81. My initial velocity is 0 meters per second. And we're looking for VF. So we're going to say probably VF squared is equal to VI squared plus 2AD. We're going to square root VF and everything on the right side. Make sure you get the negatives in there. Negative 9.81, negative 27, and I think you end up getting positive 23 there. Good. One more today. It's not the same one. Oh, it's not the same one. You got to read it more carefully here, Bruce. A clown throws the ball upwards at 10 meters per second. How long does it take the ball to return to the clown's hand from the maximum height? And what's the ball's final velocity? Let's kind of work through this a little bit here. The clown throws the ball upward at 10 meters per second. We'll call that VI. Ball goes up like this and then comes back down like this. We want to find out how long it takes during this time interval. We want to find out how long it takes the ball to fall, not to go up and back down. I think it might be easier to do question B first here. How fast is it moving when it returns to the ground here? I think it might be easier to do that one first. Anybody have any ideas? Maybe I'm wrong. Maybe it's not easier to do that first. Anybody have any different ideas? We do know, by the way, that A is negative 9.81, right? What would VF be? Not zero. Not zero. VF isn't zero. What is it? Look at this, guys. If this ball starts at 10 meters per second, slows down at a rate of 9.81, and stops at the top, and then speeds up at a rate of 9.81 over the same distance that it slowed down at, how fast is it going to be moving when it hits the ground? 10, right? You can't start at 10, slow down at a certain rate, speed up at the same rate over the same distance, and get a different speed. It's going to be the same speed, different velocity, because it's going to be negative 10, but it's going to be the same speed. We're going to say VF is equal to negative 10 meters per second. Well, now that we have that, this becomes a lot easier to find delta T. Probably just going to say A is equal to delta V over delta T. Take the T up, the A down, delta V over A becomes negative 10 minus 10 over neg 9.81. Negative 10 subtract 10, which is, of course, neg 20, divided by neg 9.81. What do we get here? 2.0387. Got it? Is that my answer? That's not my answer. What have I done wrong? Nothing, nothing. I haven't done anything wrong. I just haven't finished yet. What do I got to do now? Sorry? Okay, significant digits, but even something a little bit more important than significant digits here. Missing something there. I got to divide it by 2. Look at what I'm looking for. How much time does it take to fall from the max height to the ground? What did I find? Time it takes to go up and back down. So if I divide that by 2, I get half the time, which is the time it takes to fall. 1.019 or 1.02. Sorry? Which Bruce says is the same answer we got in the last one. Hey, go figure. We want to find the time that it takes the ball in this question to go to its maximum height. Go figure. That's going to be the time that it takes to fall back down. It's not a coincidence that it's the same time. Okay, let's see what we can do with this question, please, on page 60.